Hello, this is Britt Caswell with another video example. This example is from section 1-2 in the SavvasRealize Algebra 2 textbook. This is example 4. In this example, what we are doing is we are doing a combination of transformations. So instead of just doing a stretch or a compression, we might take it a step further and then translate it somewhere, or do a reflection possibly. So what we need to do when we think about a combination of transformations is we actually need to have a little order of operations for that combination, alright? So if ever we do a mixed set of transformations, like you see here in part A, there's a reflection and a translation, you need to first do any stretches or compressions first. Then you need to do any reflections. And then you need to do the translations last. Okay, if you do it out of order, then what's going to happen is your graph isn't going to show up right. It'll put your graph in the wrong position. Alrighty, so let's take a look at our first example. So in this example, we have a negative here in front of all the function notation. So if something is in front of all the function stuff, it's not within the parentheses, that's going to be a vertical change. And because it's a negative being multiplied there, this is going to be a reflection. That means it will reflect it here across the x-axis. And then our second one is this plus 2. Notice that it's inside of the grouping symbol, so this is going to be a horizontal change. It's addition or subtraction, so it's going to be a translation. And with it being addition, that means that it's going to move to the left. Remember, the things inside the grouping symbols tend to feel a little backwards, right? With plus 2, we usually want to go right, but in the grouping symbols, it flips it the other way. Alright, so now that we've identified what transformations need to happen, now we need to pick the order in which we're going to do it. So we don't have any stretches or compressions. We have a reflection, so that goes first. And then we have a translation, and that goes second. And now we're ready to go. Now when I graph these things, I tend to think of them kind of like saving a Word document or something. So I'm going to have a bunch of different versions of it, and every time I go to do a new one, I'm going to do it based off of a graph, like the most recent graph that I drew. Alright, so first I'm going to reflect vertically. So the easiest way to do this with a graph is just to look at the distance from the x-axis and then mirror it across. So this anchor point, for example, is 2 above, so I'm going to go 2 below. This one's 4 above, so we go 4 below. 3 above, 3 below. 3. This crosses at 5, so -5. And up here, it's all the way up at 7. Do your little Harry Potter zigzag right there, and bam. You have a very rough sketch of our vertical reflection. So now I'm going to do my translation. And it's important that you do the translation based off of this most recent one. Alright? So I could have up to 4 different transformations that happen at a time. So it's important to keep track. I recommend that while you're taking notes, you maybe have like colored pens or colored pencils or something to help you to keep track of which graph goes with which transformation. Alright, so this one's a horizontal translation to the left. Okay, so I'm going to go to the left by 2. So each of these anchor points is going to get scooted over by 2. And you see sometimes it can be a little confusing because your graphs might overlap a little bit. it is, so this blue one is the solution. Okay, let's try another one. Alrighty, so for this one, we have a 1/2 that's in front of the function, so it's outside the grouping symbol, so it's a vertical change. It's multiplying to the f of x, so it's either a stretch or a compression. So we have to identify, is this between 0 and 1, or is this bigger than 1? So 1/2 is between 0 and 1, so this is a vertical compression. So those are on our list first, right? Stretches and compressions. So I'm just going to put a 1 next to it because I know I'll be doing that one first. And then we have a +3 here. Notice that it's outside of the grouping symbol, so again, this is vertical. It's addition or subtraction, so it's a translation. And with a vertical translation where I'm adding, it's going up by 3. And since this is the only other operation we're doing, this is going to happen second. So let's go ahead and let's give it a shot. So first is our vertical compression with the 1/2. So what we do is we look at the distance from each of the points to the x-axis, and we cut that distance in half. So this one, I apologize, I just woke up. There we go. So this one, the distance is 2, so I'm going to go up by 1. This one, the distance is 4, so I'm going to go up by 2 instead. The 3 is going to go to about 1.5. The 5 is going to go to about 2.5. And the 7 goes to about 3.5. So notice if I, kind of like in my last video, if I draw my hands at the top and bottom here, and I were to push the graph in, that it would kind of squish the graph. And so this is where you're seeing that graph get squished with the silly putty. Alright, so now let's look at the translation. So remember, we're going to be doing it based off this green one. The blue one no longer matters, okay? And so I'm going to be moving this up by 3 units. So for each of those anchor points, we're going to go up by 3. Those little halfway markers can be kind of a pain in the neck, especially if your grid's really tiny. But there we go. So this lime green one is the solution. Now this example is really cool in that if you were doing this in your online textbook, this is actually a manipulatable graph, so you can move those points around. So if you haven't done it in your online textbook, I really encourage you to do that with those points. So let's identify our transformations. Let's start with this 2. So this 2 is inside of the grouping symbol, so that means that it's a horizontal change. It is multiplying to the x, so it's either a compression or a stretch. Now if this was outside, it would be a stretch, right, like the last problem. But remember, if a number is bigger than 1 inside the grouping symbol here, this is going to be a compression. We don't have any multiplications for a reflection, so, oh, and this is first on the list anyway, so here's first on the list. There's no reflection, so that would normally be second on the list. So now let's look at this minus 4. This is outside the grouping symbol, so it's a vertical change. It's addition or subtraction, so it's a translation. And with it being a subtraction, that means that it's going down. And that's the second thing we'll do. So first we're going to compress this horizontally, and then we're going to translate it down. So when you go to do a horizontal compression, we're doing purple for that, remember I always recommend just doing the table of values here because it gets a little hairy, okay? So our x values, we have 1 at negative 4, 1 at negative 2, 1 at negative 1, and 1, 7. Filling in those y values, that's f of x, just so you know. This one's at 4, and that one's at 2. Right, so these are the current ordered pairs. So remember, in order to do that horizontal compression, you factor the 2 out from anything else in the parentheses, so that's just the x, and that's okay. You find the reciprocal of it. The reciprocal of it is 1/2, and then you times that by all the x values. So I'm gonna multiply that column there, and that's gonna give me my new x values to my ordered pairs. Now all these y values that are here, those can just sneak their ways into the ordered pairs. We could still have the 2, 4, 3, 7 here. So 1/2 of negative 4 is negative 2. Negative 2 times 1/2 is negative 1. Negative 1 times 1/2 is negative 1/2. And 1 times 1/2 is 1/2. So those are our new ordered pairs that we're going to graph for that horizontal compression. So we have negative 2, 2, negative 1, 4, 1/2, or negative 1/2, 4, and then 1/2, 4. And then we just connect them. So notice all that we did was we took the x values and we scooted them in by half. Now if something was being added or subtracted in that grouping symbol, it's important to know that this would have been a little bit different because that horizontal compression would have also affected the translation. Okay, so you have to do this method. I know sometimes it looks like you should just be able to scoot them over by halves, but if something gets added or subtracted in here, it kind of messes the whole thing up, and I think we see that in the next example. Yeah. Alrighty, so then our second transformation is to translate everything down by 4. So we take each of these anchor points and we give them a scooch. So down 4. You want to be careful with your points. Make sure they're not too messy. It's hard not to make them too big. And here we go. And so now that dark purple is the solution. Alrighty, so now let's take a look at number 4. Number 4 starts, well, 4b I should say, sorry. So 4b starts to get a little spicy because now we have 3 transformations happening at a time. Alright, so we have this 2 here. That's going to be a horizontal compression. But because there's more going on in this grouping symbol, before we identify these and can go any further, because there's a number in front of the x here, we have to change our equation. So I'm not even going to bother with the other ones until I've put the equation in the form it needs to be in. Okay, so I still have my y equals f. And so all that I'm going to do is I'm going to factor a 2 out of this expression. So I'm going to have a 2 here, then parentheses. So 2x divided by 2 is just x, minus 3 divided by 2 is 3/2, or 1.5. And then we put the minus 2. Alright, and so now we have what we need in order to graph it. Alrighty, so we said that we have a horizontal compression. I'm just going to put H compress. I think that makes sense there. Here we have a number being added or subtracted in the grouping symbol. So because it's in the grouping symbol, it's a horizontal change. It's addition or subtraction, so it's a translation. And it's subtracting the 3/2, which means that it goes to the right by 3/2. And then on our last one, it's addition or subtraction outside of the grouping symbol. So because it's outside the grouping symbol, it's vertical. Because it's addition or subtraction, it's a translation. And because it's subtraction, that means it's going down. Alright, so I'm going to compress this, and then I'm going to translate, and then I'm going to translate. Okay, so. And it doesn't matter the order that you choose to translate it by. The only thing that matters is that you compress, and then you do these things. Okay. Alrighty, so now, remember, with the horizontal compression, you want to kind of do a table of values first. I'm going to do it over here. So here's my x, here's my f of x. I'm just writing out the ordered pairs for my anchor points. They should be the same ones as up there, right? Because it's the same graph. So that's why I'm going to go real fast marking those, okay? Alright, now this is the same transformation, right? In the part A, we went ahead and we compressed it by taking that A value and finding the reciprocal. So 2, we flip it into the reciprocal, that's 1/2. And then you times it to the x. Okay, so I'm going to have the same ordered pairs for my compression as I had in the example above. That's why I'm able to go so fast with picking out the points. Alright, so let's go ahead and mark those. -2, 2, -1, 4. So boom, there's the compression. So now the part that's different is this translation, because originally looking at it, you would think you'd be translating it by 3 to the right. We're not. We're only going by 3/2. Okay, so that's about 1.5 boxes. If you are a mixed number person, I'm not, but there it is. So each of these points are going to go to the right by 1.5. 1.5. 1.5. Alright, so there is that horizontal translation. And then now I'm going to do my vertical translation. Alright, so I'm going to go down by 2 on all of these. Nope. That one's not on the point. That's at the halfway marker. Sorry. Down by 2. Down by 2. 2 and 2. Alright, so now the yellow one is your solution. Alrighty, and so we'll be having a lot of additional practice on this, so keep an eye out for it. But until next time.